I didn't even write my working out. I thought the markers understand if I write angles on the diagram, they'll understand my reasoning.
It's pretty funny. It's not unheard of. It's probably something I would do as well.
I wrote from angle chasing, this works. And the angle chase was probably false anyway.
Okay, so I don't know if you remember this question. It said if you have a triangle, okay, and it has the property that for any point on the base, if you draw the feet of the if you altitude things to the other two sides, join the line and then reflect it about that line you made, the point somehow lies on the circle. If and only if it's like a 90-degree 45 triangle. Does that make sense? Okay, so so with these kind of questions, if and only if, proving two directions, obviously proving one direction can be very worthwhile for partial points. And I mean, everyone would probably reckon this direction's easier, right? Yeah. So let me just recount what I did for this direction. So basically, what I did for this direction was a chord bash.
Chord bash, oh no. Yeah. I think I just solved synthetically in about 1 minute.
Yeah. So let me just tell you something about the chord bash. That if you just do the normal unit circle thing and put the triangle like this, the answer comes out very easily. So it's easy to find these points. It's easy to join the line. So it might be easier, instead of reflecting about this line, it might be easier to just literally intersect the line with the circle that's perpendicular, and then find the midpoint and show it's on this line, yeah? Does that make sense? And I guess if people are interested in actually carrying that out, they can. But the weird thing is, and maybe this is because we didn't have dinner, is that if you did the axes, if you tried to be funny with the axes and maybe make these the axes, it didn't work out so easily. So yeah, definitely stuff to be careful of when doing these kind of things. And in general, I think chord bashing question 1 is a bit of a risky thing to do. Okay, so how did Yasser do it synthetically?
Wait, should I put this iPad screen? What's the whiteboard?
Wait, you didn't do if and only if in one shot, right? You just did the only if?
I did the only if in one shot.
Okay.
It's like a geometric. I remember James Bang was talking about this question. He said, "Our geometric functional equation," because this is, I think it's pretty much a geometric functional equation.
Yeah, I guess. Yeah, I'll make a point of that after this.
Oh wait, I just opened.
So for the synth, what did you show for the synth?
Where's the Wait, should I
Well, actually, maybe
go
I
on the
should
screen?
ask Leo and the others. Did you do this direction? Just you probably already did this direction though. Oh, okay.
Oh, wait, I just opened the whiteboard.
Yeah.
I'll just get on the whiteboard. 720.
Oh, actually, I actually made a slight mistake when I was doing this synth. Maybe people could spot the mistake. So, if you have triangle and take a point, get like a square. So you kind of want to show that this thing lies on the circle. And whenever you have two circles kind of intersecting, this first intersection point is just reflecting to the second intersection point. So all you have to show is this triangle is like the reflection of this other triangle about this line.
Wait, oh, is that meant to be wrong? Wait, hang on.
So so I'm claiming this is an incorrect proof. You know what I'm trying to say here? So if you can show that, so you got this rectangle here, right? And you reflect the bottom triangle. Maybe I'll put this in green or something. So if you can show that the green triangle reflects to the top red triangle, maybe you call it the black triangle, then this would have to be the other point of intersection. I mean, it's not totally wrong. I think the idea is there. Well, why is it not like a proof?
So wait, so what's the thing you said you're trying to prove again?
What?
So
Right,
it's
what'd
an
you say, Yasser?
isosceles trapeze. So it's an isosceles trapezium, and you take perpendicular bisector.
Yeah, Leo's right. So you have to show this line actually goes through the center, yeah.
Oh yeah, that's needed. Yeah.
Okay, that's the missing part of the proof, I guess, yeah. How did you show this, Yasser?
Okay. Let's draw a diagram a bit below. Yeah.
Yes, I certainly did focus my efforts more on the if direction than the only if direction, though.
Okay, let's go. Okay, since it's 45. So all of these angles are just 45. We have equal stuff like that,
Yeah.
and oh, this angle is alpha. Then you have alpha here, 90 minus alpha, 90 minus alpha. This angle over here, the red angle is equal to 360 minus 90 minus 90 minus 2 alpha, which is 90. Okay, what? Oh, wait.
Oh my gosh, I've never seen an angle chase where you use the 360 before.
2 alpha, which means, wait, what? Okay, now it means that so get RPB similar to RQC.
RPD.
From RPB and RQC, similar switch. RQB and how do you know to look for this? I think the reason is here. We know usually when you have an obvious cyclic quad and not obvious cyclic quad, then it's usually there's a similar switch often involved.
Oh.
Because they pretty much forced to be similar.
Yeah, so whenever you have two circles intersecting, there's like a similar switch going on at the vertex where the triangles don't come out of.
So that means RQB and no, not RQB. Wait, RQP. RQP and RCB. That's enough because then CRB and is equal to QRP is 90. I think this idea also almost works for the converse, except now you have to kind of prove they are not similar instead of proving they're similar for the converse. So. I think I did.
C
I think I did a
CRB. Oh, is that done?
Yeah.
Wait, do people have questions? Yeah, what happened?
How do you know? CQ.
Oh, he's too lazy to speak. Angle QRP is 90 degrees.
Oh, so that's the reflection.
Oh, the red circle goes through D, right?
Red circle. Oh yeah, it does. Oh, actually, I don't think that's that particularly important. Yeah, I think it does go through D, but I think it's not needed in the proof. But it doesn't go through D in the converse.
Alright, any questions?
No, wait, it does go through D in the converse. I know it doesn't go. Wait, no, it doesn't go through R. It doesn't go through R in the converse. Yeah, wait.
No, I'm going through the other direction now.
Oh, actually, similar switch might not work for the converse.
Wait, is Leo okay with this so far? Where's Lucas? Okay, so for the other direction, so it's actually kind of a weird thing. It's like I'm trying to make these generalizations about question ones, and it never seems to kind of follow the pattern. But um, so in the other direction, so the key for the other direction. So I don't know how many of you noticed this, but this point D, okay, it's for all D. So this is the key. So did you know that it was for all D? Yeah, so for all D, so whenever you need it, whenever you use a statement for all D, it kind of, so obviously, there's like, there's like uncountably many choices of D, right? So the skill is kind of in finding a finite subset of D's for which, or a nice choice of D that should get the job done. Okay.
Who's the person in blue text? Is it
So you don't.
Alex?
Good. So if you don't make any assumptions on D, it's gonna be really tough. But but so the complex bash might still work. It's just the equation will be kind of weird in the end. So the equation will be like it'll be an identity for all D. So then when that happens, it might force the angle to be 9 degrees. Maybe I'll try the complex bash while Yasser's going through the other questions. All right, so so if you look at this diagram, like what choices of D do you think could be nice? Like what kind of choices of D do you have in your mind maybe? Yeah, so all these midpoint things. So if this is like the midpoint, so if it was like the midpoint, this would be like the median, you know? So it could be the midpoint, that's an obvious choice. Not related to the actual question, but just from your, yeah, it could be the feet of altitude. What else? This is kind of like, is this Geometry Revisited Chapter 1? Knowing where the positions of all these kind of points are, yeah? We know the midpoint. We know where the feet of the altitudes are. What else? Yeah, angle bisector theorem. Anything else?
What if we do limit as it approaches B?
Maybe like median limit as approaches B, so the endpoints.
Yeah.
And so there's lots of special points. So like the in circle, X circle points. I guess the more you know, the kind of like the harder this question is, right? Well, I mean, if you don't know enough, it's impossible, I guess. But I kind of just want to list these. It's quite a lot of points. Yeah. Can you see if one of them would actually be pretty nice to go in here?
I think I know what I would choose.
Just thinking about it on the board. Okay, so
Okay,
if
yeah,
there
I
were
think
the
I would have
five
gone.
options, which of the five options would you pick? Uh, anything with five options. All right, pick one of the first five options of this quiz poll. One for midpoint. Okay, we have two people who haven't voted. Wait, unclear means in circle, X circle points, yeah? It doesn't mean you don't understand. Okay, anyway, so looks like Leo's suggestion was the most popular one. Can you see this is a good choice? I mean, basically the angle bisector is equidistant from the two lines, right? So it gives you these are equal. This may or may not help, but it's a very nice setup. People tell me what happens from here. What? Okay, sorry I'm using your color. We can use another color. What has to equal?
Wait,
Alright, maybe let's not spoil it.
angle bisector. Oh, wait. It's actually nicer than I expected. Wait, hang on. How did that?
Hold on, let's see if maybe Leo can draw on the board so I can see what he's got. Hmm. Hmm. Alright, are people kind of realizing what's going on now? I'll give it a couple of minutes. Okay, so maybe chase some obvious angles.
Angle bisector.
Alright, should I keep going or wait?
Angle bisector.
Okay, I'm not spoiling it then. I'll give more time.
Wait. So pretty much a lot of angles that are equal to alpha. A lot of angles that's
Yeah, let's not spoil this.
oh wait, I just realized that my diagram hindered me from seeing it.
I guess every diagram you draw has to be wrong because of the condition. I think Alex got it. Just trying to control himself from spoiling it.
Okay, maybe need to be like Alex no more spoiling.
Is R the reflection? Okay, so I think. Okay, so this is this angle. You can see this. It doesn't look 90 degrees, but according to our assumptions, it is. And yeah, it's like this. This you have to be willing to draw a wrong diagram. Okay, so if that's 90 degrees, and these triangles are all congruent, these lengths are also equal. Yeah, so actually you didn't even need to know those lengths were equal because the reflection property tells you that D reflects to A, right? Okay, so how does it finish it off from here, Leo?
Has Leo gone? Then is square. Next thing.
Okay, good. So you get 90 degrees, yeah? Um, so if you know D reflects to A, this is like P and Q, and you know P and Q are fixed, right? And then you know the angle, for example, you know the angle here reflects to the angle here, right? So the dot equals the open circle. So not only is the dot equal to the open circle, it has to be equal to 45 degrees, right? So then this is 90 degrees. And what's funny is, you know, like, there's actually a lot of things you can do if you're stuck in this problem. One of the things you could do is, if you could show it was 90 degrees, So if you know it's 90 degrees, right? Can you then prove these angles have to be 45 degrees? And the thing about this is you can do that with or without having gotten here, okay? So this is something that definitely came up in brainstorm before we got here, but now that we got here, it proves that this will be worth points, okay? So if this direction was worth 5 points, I think this step would be worth 1 point, maybe. Or 2 points, I don't know. So I guess now we're left to show if you have a 90 degrees, can you prove it has to be here at the top, basically, yeah? Crystal's here. I should wish her luck for APMO as well. Tuesday. Alright guys, so what are you guys thinking about for this? So we know the triangle is 90 degrees, and any point on the hypotenuse reflects about some line to the circle.
Okay, I think the synthetic I had works. For the once you prove it's 90 degrees.
Yep. So not spoiling it. See if there we go. So notice how Leo was thinking about the same thing we did before, right? You're still picking a point for D, remember? That doesn't change just because the question is simple and almost done, okay? You're still for all D, okay? Sorry, only Leo can see results. Okay. And in particular, Yasuru cannot. But
You know what?
okay, so
Can we say results? This AMO results. No wait.
yeah, I guess we're trying not to spoil as much as possible, but in some sense we're trying to go with Leo's pace
Or
here as
results
well.
for the question.
Okay, so if you take the midpoint, which is the center of the circle, right? Can you see how this works? So I think they all have to be midpoints, right? So this has to be parallel. this. Right, so do you see how this works?
Okay.
Wait, Lucas, did you already see this?
Midpoint line thingy.
Okay, so basically, I mean, this length here, is equal to this length here, which should also be equal to this length here. So, for that to be the case, this would have to be over here. Yeah, so I'm trying to kind of build this kind of argument that all the question ones are one-shottable in some sense, but like as you look at the
Meanwhile,
questions, it's
there
kind
was
of
that geometric inequality. It was 5-shotted.
yeah, like I kind of want to say that they're all one-shottable, but I know that saying it would be misleading. So I just that's what I want to explain by the end of the day. Sort of what question ones look like. Because, even though question ones are kind of trivial for most tests, there's something about the question ones of this test that make all the people do bad. Okay, so that's it, I guess, for that question. Yeah, so I guess one thing I should mention is, the problem-solving technique that's relevant to this question would be just to draw the 90-45 triangle and see what kind of things are true for that. And you can maybe prove for the big one, but when it's one-shottable like that, it's kind of and you if you look up the official solutions, it actually is the same as this. So it shows you that like it was actually the intent of the problem as well. Yeah, so that for all D thing, even it's like it's almost daring you to one-shot it and doing one direction and using the direction to give you ideas for the other direction could be helpful, as well as trying to prove that 90 degrees implies isosceles will get you points even if you don't get that as 90 degrees. Alright, any questions? Okay, so shall I hand it over to Yasser for question 3?